Hello friends, in this video tutorial let us see some of the SQL query tuning tips. So for this let us go to SSMS. Now in DB underscore test database there is a table called sales underscore orders. So let us understand the structure of the table. So it has got the following columns. The primary key is order ID. Okay, then there are multiple columns like customer ID, employee ID, order date, required date, shipper ID, freight, ship name, ship address, ship city, ship region, postal code, ship postal code that is, and ship country. Okay, these are the different columns. And let us understand which are the keys. The right now only PK underscore orders, that is only the primary key is defined. And let us understand which are the indexes. There is only one clustered index on the primary key and one non-clustered index on order date. Okay. Now I have just restarted the SQL Server instance. Okay. And so if I execute this query, okay, then it will not show any records. Now what is this query doing? It is querying the dynamic management view, that is DM underscore DB underscore index underscore users underscore statistics. So which are the different indexes which are being used in this particular database, that is DB underscore test database. That is what is shown by this particular query. Okay, so let me again execute it. Right now it is not showing any records. Why? Because the instance has just been restarted. Okay, so that's why there is no index which has been used till now. Okay, that's why after the last restart. Okay, now let us execute a very simple query, okay, on the sales order table. That is, let us select 3 columns from the sales order table. Now note that there is no where clause, okay, and so hence, and there is a cluster index defined, okay, on the sales underscore orders table. So that's why the cluster index will be used to see the records, right, to query the records. Okay, so let me execute again, go to execution plan, and we can see that the cluster index scan is being used. Okay, fine. Now although where clause is present, now let me go to the second query. In this query, let me add a where clause on the ship city column. Okay, so in the ship city column, for the ship city column I added the where clause. So although the where clause is present and it is selective, why? Because it is only getting 3 records out of this table, right? But there is no index which support the ship city column, and so still cluster index scan is used, right? So if you go to the execution plan, we can see again that the cluster index scan is used, although we are having where clause, and which is very selective in nature, but there is no index defined to support this where clause column, right? And that's why the cluster index scan is used. Now let us go and see some more examples where the query may be performing slower. This is a case where the query is performing slower because of lack of index. Let us see some more examples where the queries will be performing slower because of lack of indexes. Okay, because of indexes which are not defined. Okay, so let us see one more such example. In this example, we are aggregating based on ship region column. Okay, and we are then grouping by ship region column. Now this query will also use cluster index scan. Okay, and in order to perform the aggregation, it is using hash match. Okay, hash match aggregate. Now all this is happening because there is no index defined on the ship region column. Okay, so this is also a query in which performance can be improved with the help of non-cluster index getting defined on ship region column. Okay, and see over here, the hash match aggregate operator is consuming 58%, that is almost around 60% of the cost. Okay, so that is a very important thing to note over here. Now let us see one more example in which index can make a difference, right? So let us see, select ship region from sales underscore orders, group by ship region. Okay, order by ship region. So sorting operation is performed in this particular query, and as the sorting has to be done based on ship region column, but still there is no index on the ship region column. So let us see how this query is performing. Okay, So it is again cluster index scan, but the important thing to note over here is the sort operation is consuming 58% of the total query cost, which is around 60% of the cost. So all these queries are candidates for performance improvement with the help of indexes. Okay, so now let us go and again run this query to find the index usage. So now the sales underscore orders table, for this particular table, user scans have been 5. So all these user scans have been clustered index scans, right, on the primary key, that is pk underscore orders index. Okay, fine. There are no user 6 and no user lookups till now. Okay. Okay, so now let us go and create a non-clustered index on the SIP region column. Okay. So now the index has been created. Okay, now again execute the same query, okay, for the aggregation. In this case, for the SIP region column based on which we want to aggregate the data, for this particular column, the index has been defined, non-cluster index has been defined. And so let us see what happens. Now in the execution plan, we can see stream aggregator is used, and stream aggregator in general is faster as compared to hash aggregator. And you can see clearly that out of the total query execution, only 9% of cost is being consumed by this aggregate function. Okay, so which means aggregation is happening faster, the aggregation operation is happening faster for this data if the column on the basis of which we want to perform aggregation has got an index defined on it. Okay, fine. So that's how the query plan changes. Okay, and that's how it improves. Okay, and we have already discussed that instead of hash it is using stream aggregation, and this is quite fast, okay, as compared to hash in most of the cases. Okay. Okay, now let us see the order by query. Okay, in order by query, now as the index has been defined on SIP region column, we can see that index scan is performed on the non-clustered index because there is only one column that we require in this query, and on that column non-clustered index is already defined, so index scan is performed. And the most important thing to note over here is, although we have specified order by clause, there is no sorting happening. Okay, and that is just because of the index which is defined on the SIP region column. So we are able to omit the whole sorting operation. Okay, and that saves considerable cost to the query. Okay, and so the query performs very fast as compared to the query which has got the whole sorting to be done, right? So it is all happening only because the non-cluster index on the SIP region column is defined, based on which the ordering is required. Okay. Okay, now let us go again and execute this query to understand the usage of the indexes in our database. So we can see that now this remains 5. Okay, earlier also the index cluster index scan on pk underscore orders index was 5, and right now also the count has remained 5. So both these queries have not used cluster index scan on pk underscore orders, but they are using the index scan on the new index that we have defined, which is a non-cluster index, and that is represented over here with the value 2. So both queries have independently used this index once. Okay. Okay, now let us drop that index. Okay, so we are dropping that index. Okay, now let us create 2 more indexes. Okay, so we want to create index on CT and we want to create index on ID, that is customer ID. Okay, fine. Now one more thing to note over here is, whenever we use in operator, okay, the query optimizer internally converts that into multiple OR operators, okay, for the same column. Okay, and that's how it executes that particular in operator list. Okay, okay, now having discussed this, let us create these 2 indexes that we are discussing. So now let us go and verify. Let us refresh. Okay, so now along with the order date related index, we also have customer ID related index and SIP city related index, right? Okay. Okay, now let us execute this query. Select three columns from sales underscore orders where ship city equal to this. Now, as we have a where clause in which we are using a column and which is selective in nature, okay, and the most important thing is index, non-cluster index is defined on this particular column. So now what will happen is it will use the index seek, okay, so it will go as per this index, okay, and then for the remaining column which is see customer ID, okay, customer ID is not available in this index, right? So in order to get customer ID, it will use the key lookup on the primary key, okay, and based on the primary key it will find out the customer ID for each record, okay, and that's how this nested loop occurs, okay. So but this is still better. This will give better performance because we are only interested in these three records, right? When we do this particular index seek, okay, we get only we are only interested only in these three records, okay, fine. So see, the actual number of rows is 3. In this, the actual number of rows output is 3, okay, and that's why it has to do this looping operation only for the 3 records, right? So this particular query will perform quite fast because the index is defined on the where clause column, right? Okay, now let us do the same thing for customer ID. Now on customer ID also the non-cluster index has been defined. So let us execute. It will have a similar plan. It will have index seek based on the non-clustered column, that is customer ID related column, and then it will do a key lookup on the primary key, okay. So this will also perform quite fast, okay. Okay, because the index seek will give only 3 records, okay, and based on these 3 records, just in order to get the other column, it will do a key lookup on the primary key, okay. Okay, now let us see one important thing. Now let us combine these two queries, okay. See, the columns which are output by these two queries are same. The table from which we want to get this data is also same. The only thing is in where clause. Now let us combine these two conditions with a OR operator, and we will observe that if we do this, then it will not use any of these index. So although we have index on the first column, although we have index on the second column, okay, but if we are combining these two columns which are very selective in nature in the where clause, if we are combining these two columns with a OR operator, then SQL server will not use any of the two indexes defined on any of the columns, but it will go ahead with the clustered index scan. So as we already, let us execute this query and let us go to the execution plan, and here we can see it is using clustered index scan, okay, which is not as efficient as the earlier case of using non-clustered index seek, okay. So again our query is now becoming slower, okay, just because of the OR operator, okay. Now what if there is an AND operator? If there is an AND operator, the query optimizer can still rely on the non-cluster index. It will use one of the non-cluster index, and then it will use key lookup on the primary key to get the other column, okay. So let's say if it uses ship ID non-cluster index, then just in order to get the customer ID column, it will use the key lookup on the primary key, okay. So let us execute. So go to execution plan, and that's what is happening, which we have discussed. That is, it uses a non-cluster index. In this case it uses ship city column, and just to get the customer ID column, it does a key lookup, okay, with the help of primary key, okay. So this is more efficient as compared to the OR operator, because OR operator again goes and scans the whole table with the help of clustered index scan, whereas this query still uses index seek and then combines the data with the help of nested loop and key lookup on the base of primary key, okay. So this is that's why we can conclude that this AND operator is performing better as compared to this OR operator, okay. Okay, now let us drop this index on the ship city column, okay. See, the problem that was occurring in the last example was, okay, let me just go and again create that index. Okay, let me show you one problem that is occurring. Okay, see, the one of the problem that is occurring is index seek is fetching us 3 records. Okay, it can be seen over here also. The actual number of records rows is shown as 3, so it is outputting 3 records which will form the part of the final output. But only thing missing is customer ID column. It does not have information about customer ID column, and so it goes and does a key lookup on the primary key just to get the information about the customer ID column. And this query can still perform quite better if we are able to eliminate this key lookup. That is, what if all the data related to the query is obtained from within the single index, non-clustered index. If that can happen, then it will work fastest. Okay, so let us drop this index on SIP ID column, SIP city column, and again define a new index on the SIP city column which includes this remaining column, which is customer ID column. Okay, and now if you execute this query, okay, then it will give better results. Why? Because this kind of index is called covering index. For this query, there are only 3 columns required, right? SIP city, customer ID, and order ID. Okay, order ID is part of primary key. Okay, and we are defining a non-clustered index on SIP city. Okay, and then we are also covering customer ID. Okay, so all the columns are covered as part of this particular index. So this kind of index is called covering index. Okay, fine. And such covering index can get data for this all these 3 columns just from the index itself. Okay, primary keys is the reference to primary keys are stored within the index. Okay, so that is not required. Only the missing column was customer ID, which we included in the leaf nodes. Okay, so this kind of queries are called indexes are called covering index for the query, and this will work in the best way possible. Okay, so now let us use once that index has been defined, let us go and query with the help of OR operator and see what's happening. In case of OR, it is doing non-clustered index scan, so which means on the new index that we have defined. Okay, it is using the new index that we have just defined, this covering index. Okay, this index. Okay, which means it is able to read all the records, all the data, all the columns. Okay, so this particular query is able to get all the columns required by this query from this single index because it is a covering index. So it does not have to do any lookup operations. Okay, so we have eliminated the lookup operation, but in this case it is doing index scan. It has to scan the whole index, that is all the records. Okay, for this particular column, based on this particular column, SIP city column. Okay, now as we have eliminated the lookup part, it improves the performance. But now let us go and see the best performance. If it is, let's say we replace, if suppose we, as per our requirement, if we have AND over here instead of OR, then that can perform in the best possible way. Let us execute. Why? Because see, all the 3 columns are available as part of this covering index, correct? And second, and the most important thing, as this is an AND operation, it can seek to the specific records and get the data from that records. Okay, so we can see over here that it is using index seek for the non-clustered index that has been newly defined. That is the covering index, this covering index that we have newly defined. So instead of a index scan that happened for OR, it is now doing index seek because it is AND operator. Okay, and as all the 3 columns are available as part of this covering index, it is just doing index seek on that particular index, and this kind of queries will work in the best efficient manner possible. Okay, and that's why I've written over here index seek in case of AND operator, that is over here. Okay, this index seek that is happening, okay, is far better than the index scan in the case of OR operator. Okay, so in the case of OR operator, index scan was occurring, and whereas in the case of AND operator, index seek is occurring. Okay, and this index seek is efficient, more efficient as compared to this index scan operation. Okay, so I hope friends this video tutorial on SQL query tuning tips is useful to you. Thank you.